Okay, so today we're starting washers. So when we did discs, the disc method with rotational solids, the way the disc method works is that you end up having this area, this bounded area right here, where it ends up being rotated around a line of rotation. The disc method occurs when this bounded area is sitting on your axis of rotation. This radius right here ends up being the radius of the solid at that same point. Okay, so as this rectangle, and we started with rectangles when we did areas under curves, represents this cylinder here in my three-dimensional solid. And we use the equation integral, which is just basically pi r squared, pi radius squared. Okay. Now, that's only if my area, my bounded area, is sitting on my axis of rotation. So the disc method is what we use when it's sitting on it, but the washer method, if there's a gap or some kind of missed space in between my area, my bounded area, so this is my bounded area now, and see how there's a gap here, when that happens, that rectangle right here, as it rotates, creates what we call a washer, kind of like in construction where you have a washer that goes around like a bolt so that it puts the force on a greater area. Okay, but as you can see, when we revolve this around this rotational piece, you can see this area here, that's the part that's rotated, and right through the middle there is a hole in it. Okay, and just like what we did before, this is kind of like what we did in geometry where you had a circle and they'd say, okay, find the shaded region, and it was something like this, where you actually had to find the area of my big circle, and then you'd subtract out the area of the little circle. Well, that's basically what we're doing with washers. Matter of fact, the equation, if you look at it, looks like this. Which again is pi r squared minus pi r squared, and it's the big radius minus the little radius. And you can see this distance from here to here is our big R, and this distance from here to here is our little r. Big R, little r. Big R, little r. So you can see where this equation comes from that we're going to be using. Okay? So, do a small example problem, one that we've done with disk before. So we're finding the volume of a solid of revolution formed by moving this bounded area around the y equals 1 line. Okay, so we have our quadratic here. Y equals x times x minus 5, which means I have zeros at 0 and 5, and it looks something like this. Okay, the other equation that we're going to be using is y equals 0, so this ends up being our bounded area right here. Okay, but we're going to be revolving it around the y equals 1 line. Okay, which is this line right here. This is our axis of rotation. Okay, now again, one of the things I tell my students to do is to reflect this area. So I'm going to reflect the area over my line of rotation, and it's going to look something like this. Okay, and if we revolve it, it's going to look like this. So that middle piece you see right there, if we pulled it out, it would look like this, where this is my big radius and this is my little radius. And again, you can see it right here. This right here ends up being my big radius. This is my r. And then that means that this is my little radius, little r. So my big radius is going to be still function on top minus the function on bottom. So my top function in this case is 1 minus my bottom function, which is my x squared minus 5x. My little radius, the function on top is the axis of rotation as well, 1 minus the bottom, which is 0. So this ends up being 1 plus 5x minus x squared for my big one and 1 for my little one. Okay, so those are my radiuses. So remember, we're using this equation. Theta from 0 to 5. Oh, this is just from A to B. Sorry, haven't gotten to that part yet. So since we're doing a horizontal axis, that's my equation. And then we are doing it from 0 to here to 5. So that's my upper and lower limits. So pi from 0 to 5. And 1 plus 5x minus x squared squared minus 1 squared. Now, I do want you to realize that if you look at this, this inside right here, this hole, is basically nothing more than a cylinder being cut out right through the middle. That's what this represents. It's a cylinder with a radius of 1 and a height of 5 being pulled out. So we can simplify this. So we have to FOIL out our trinomial and then subtract 1. So we get x to the 4th minus 10x cubed plus 23x squared plus 10x dx. And then we end up with, when we take the antiderivative and plug in, we end up with that as my volume. Okay? And I'm not going to go through all the algebra right now. But that's basically it. It's the same thing as the disk method. The only difference is that instead of coming up with one radius, I have an inside radius and an outside radius, a big radius and a small radius. So it's relatively simple. Your code for today is P00L P4RTY. P00L P4RTY. I wanted something kind of summary today. But that's it. Basically the same equation, same steps. The only difference is I have to find two radiuses instead of one.